Hello everybody and welcome back. And in the previous video we saw that we successfully created a simple Python server that was able to actually receive and accept the connection from our different terminal. We were able to netcat on our local host on the specified port in the program, and it actually printed out that the target was connected. So what we want to do right now is actually, let us do something like this. So let us exit this. So exit. Whoops, I did not want to, I wanted to open Tilix. So let's open Tilix so we can split screen like this and run two programs. Yeah, I can close the terminal once I run Tilix, so let me just open it once again. I can lower this, enlarge this and put it like this. Now let me just see. Let me just see if I can change a color, since the white one is actually a little bit too bright, but it seems that we can, so we will actually close this. We'll just run two terminals instead. So let us enlarge this like this. And let's use another terminal, so new window. We want to enlarge this one as well, so zoom in, and let us get right to work. Let's zoom this one in as well a little bit. Okay, so right here I will open up our server. Whoops, let me just find it where it is. So cd python program, cd reverse, reverse nano server.py. Here we have our server, and here we have another terminal where we will code our client or our reverse shell. So we need to open up our server so we can see the different functions and the correspondent functions that we will write in our client for these functions in server. So let us actually go to the same directory, so reverse. Here we have the server, and right now we want to make reverse.py, or we can call it reverse shell.py. So we start off with the same hashtag exclamation mark and then user bin Python, so this is something that you always need to include. And we also have to import socket as well right here. So this is the standard beginning part. Right now what we want to do is we actually want to connect to our server.py. Let's see how we can do that. So with this picture right here, we can see that in the previous video we coded some of these functions. We still didn't get the send receive function, but we will code that one as well. So for now on, what we want to do is actually create the client. So what we have to specify is the same as in the server, so we have to create a socket, and then all we have to do is perform a connect function in order for our client to connect to our server. So this is a rather shorter example of code than in the previous video, so it will be rather simple. We can write it in 2 or 3 lines. So let us do that. What we want to specify right now is the same as here, so we want to specify the socket. In my case, let's call it right here sock, so we can actually differentiate it, so we don't call it in both programs S, but it doesn't really matter. I will call it sock right here. So equals socket.socket, socket.af_inet, and then comma socket.sockstream. As we said in the previous video, this is just basically usage for IPv4 address and also the TCP connection for our server. Right now, all we have to do is perform the connect function to our server. So let us do that with the function sock.connect. And in the connect function, we have to specify where we want to connect. Right now, as we can see that we binded the port 120, binded the IPv4 address of localhost on port 54321. We will have to specify the same IPv4 address and same local port in order to connect to our program or to our server. So let us do that. So open double parentheses, same as in the bind command in our server, and here specify same thing. So 127.0.0.1. Close the double quotes, comma, and then 54321. Then close the double parentheses. As we can see right here, the local port is not a string and the IPv4 address is put in double quotes, so make sure to not switch those up, otherwise it won't work. And what we want to do right then, we want to actually print that we successfully connected. So print connection established to server. This is just for us so we know that everything went good. And after that we want to close the socket. So sock.close, and we want to close the connection. So this is how this should go. Basically we run the server first, it starts listening for incoming connections, it prints out this line right here, and then we run the reverse shell.py, which will perform a connect function on our server. And basically what it will do after that, this target or this server will actually print target connected, and the reverse shell will print connection established to server, and both will close the connection. So that is how it should go. So let us save this. So Ctrl-O to save, enter, Ctrl-X to exit. Let's make it an executable. So chmod +x reverse shell, the underscore shell.py. And let's run the server first. So we run it with server.py. We get the string listening for incoming connections. And here we run the reverse shell.py. As we can see, everything went perfect. Listening for incoming connections, then we ran the reverse shell, connection established to the server, target connected, and we closed the connection on both programs. So these simple two programs work. Now what we want to do in the next video is actually establish a longer connection where we can actually send some stuff to the other target. So we will see how we can actually do that in the next video. For now on, we successfully created a simple reverse shell and a simple server that only performs the connection function. And that would be about it for this video. Hope I see you in the next one, and take care. Bye.